So, we will look into now building maintenance management as I just mentioned on the last class. So, some of those issues then we will be talking about is this is related to actually maintenance management of not usually when you talk of maintenance management of building, it is not a single one, it is buildings, number of them may be in form of an estate or single building, large building, whatever it is, it can even go up to this. So, in this context what is important is life of the building, life of the building. Now, how do you define life of an inanimate object? Building is an inanimate object. So, while living beings, they have actually a defined sharp demarcation between life and death. So, you can say that okay, this is life, and then you can talk in terms of expected or life expectancy and so on and so forth. But when it comes to inanimate object like buildings, it depends upon the context you are talking of, right. So, something we define called intended design life, intended design life, that is your intention at the initial stage beginning, right. So, intended design life is when you are actually constructing a building, or this is true for any other structure, you expect that okay, it should have a it should have a functional service life of so many years, the structure is part of it. So, you talk in terms of intended design life, right. So, intended design life is generally used in the structural design concept quite often. For example, you would possibly think in terms of 50 years return period of the wind or the wind that will come once in lifetime, right. So, this is more of notional. So, that is intended design life is what is your intention. So, for bridge it may be much higher, 100 years or something of that kind, the intended design life. So, during the design stage, whatever is the life you have actually conceived or thought of, that is what is intended design life. Really physical life would be much higher, because physically it might last much longer. You can actually do maintenance, you can repair it, and it can continue for practically infinite life. So, physical life will be infinite unless there is something kind of an accidental overloading because of largely because of natural disaster or something of that kind, not accidental natural disaster oriented overloading, which you have not really envisaged during the design, and or less accidental overloading due to human activity or similar sort of thing. Otherwise, physical life would be very long. Deterioration do takes place, and that requires repair to be done. So, for example, a bridge might have some kind of deterioration. So, it requires that you should be repairing it, and once you repair it, can bring it back to the same level as much as possible. But then there is something called functional life. For example, if it was a 2-lane bridge, since some of you are from transportation, 2-lane bridge. Now, you think that this is not right, you want to it should be 6-lane bridge or something like that. So, its functional life of that 2-lane bridge will be over, you might even abandon it and start constructing a new bridge. Similarly, building, functional life in building is of course very important, because occupancy type changes. Function of buildings depends upon occupancy type. So, if it was let us say all essentially many of them you would see that actually they were possibly theatres earlier. Now, that got converted into shopping malls, or there are various examples where actually they were residential. Once upon a time, say Chandni Chowk in Delhi, they were all residential, those maybe 150 years back, the Shahjahanabad, right. But then with the advent of let us say mid of 20th century and so on, after independence and all, what they have done is they have converted the ground floor into shops and top ones are residential, mixed occupancy. So, function changes occurred, right. Many other cases it would be similar, building remains same, but its functions change. So, functional life might change depending upon the situation, and economic life is related to cost of maintenance. This is very quickly evident in case of mechanical systems, where there is a lot of wear and tear. What happens is, you see, if you look at the such kind of machines or similar sort of thing, initially you will have some slightly high maintenance requirement, because things are not working properly, maybe a little bit of servicing is needed. As you know, in case of your car, there are free service 3, 4, 5 initially, and you do at much less periodicity than compared to a regular service which you will be doing later on, which is on kilometer or yearly basis or 6 months or time basis, either way. So, initially maintenance requirement is high, but then maintenance really comes down after a certain period of time. So, with time actually maintenance will come down, maintenance comes down, and then it is more or less same, and then starts failing. 1 or 2 parts will start failing initially, which you replace, and in the long run, when every parts have is lived its life by and large, many parts starts failing together. So, it has got a cascading effect. So, maintenance cost will tend to increase beyond a point. Beyond a point, maintenance cost will tend to increase. So, when maintenance cost increases, a time comes when, if you do an economic analysis, it is not worthwhile maintaining it anymore, because cost of maintenance is higher than cost of maintenance is higher than a new one. Economically you can justify 2 alternatives if you compare. One is to keep on maintaining the same equipment or machine, other is to have a new one. So, you can have an economic comparison, alternative comparison, and find this better. So, that is related to economic life. So, you see the lives are quite, lives can be quite different depending upon the context. Of course, in structural system we talk in terms of what is called service life of elements. Generally, elements essentially not the whole structure or building as a whole, service life, or you can say, notionally one can say service life of building is a likely time during which it will be in service, the building will be in service, right. Likely time, I mean expected service life you can talk in terms of, which will be the sort of expected time during which it will be in service. For elements we talk in terms of service life, and that one is essentially related to failure of like reaching a serviceability limit. So, in case of modern design, as you know, it must be true for all buildings, building structural elements or otherwise, even elements in pavement and things like that. You talk in terms of, one is a kind of a structure, mechanics oriented failure, collapse or similar sort of thing, mechanical failure. Other is a functional failure or some serviceability limit failure. So, serviceability limit failure means, in case of structural elements, lot of cracks or deflection or such thing, as we know. So, if I know a time when an element will reach its, it will exhibit, it reaches serviceability limit, say exhibit a crack, right, unacceptable crack, then what I will do? I will repair or replace that element. So, that is not whole structure or building, I will not do anything to, but repair the locally repair that particular element or replace it. So, that is service life of that particular element. So, in this, this is the context. So, when you talk of maintenance, maintenance is always related to the life, because during whatever life or intended life you want to maintain it, that should be done right in the planning stage itself. It has got its implication, in economic terms. Let us see what it is. So, one has to look into life cycle cost, then in life cycle cost maintenance will come into picture. Now, you might put something by design right in the beginning, which that I will go on replacing it every year, you might have a choice, or something which you might like to replace it once in 5 years. So, that decision right in the beginning you would like to make. Now, the ones which you will be replacing every year, it will be cheaper possibly. The one which you like to replace on once in 5 years, it will be relatively costlier. So, when you look into maintenance situation, you look into, because maintenance you will be doing during its service period, during its intended design life period. So, therefore, life cycle cost is what one should look into, and in life cycle cost, if you see the components of life cycle cost, initial cost I call it IC. This is in buildings, energy cost is very important in many buildings, many functional building, right. Energy cost is very important because it's a huge amount. Say academic buildings, lecture theatre complex or something, if it is air conditioner is running. So, energy cost will be pretty high. There is a operation cost, which in buildings which would include actually cost you got to pay to the municipal authorities and similar ones, also for maintaining the systems like your lift system, water supply system, you incur certain amount of cost. So, therefore, the operation cost, and then is a maintenance cost. So, maintenance cost is anything I will define what is maintenance. So, anything related to that definition of maintenance, that would be maintenance cost. The other one is demolition cost. There can be a demolition cost involved, there is a demolition cost involved at the end of its life, and then minus something you were able to salvage out of this. Supposing you demolish a building, you might get all some elements which can be you can sell. So, that is salvage value. So, DL minus SB, and these are discount factor, because initial cost is in the beginning, at the time of construction and design you actually spend that money, while maintenance cost is yearly, maintenance cost is yearly, right, next year and next or maybe 5 yearly, you can make it that way, and then this is at the end of the life, this is at the end of the life. So, therefore, they all occur at different time in the life of the building or building systems, different time, and therefore, you must bring them into same time frame, and that we do taking interest rate into account, what is called time value of money. The concept of time value of money, which is used in all engineering economics analysis of the kind that society that we are in. If I invest 100 rupees today, I should get 100 plus I rupees next year, and then 100 I next year I should be getting 100 plus I into 1 plus I, because the factor would be 1 plus I compounding every year. So, any amount today should fetch me that amount multiplied by 1 plus I, right. So, that is time value of money. So, you have several discount factor. So, depending upon what you have something called present worth. So, you can bring all the money that you will be spending later on to the current time frame, that is as if equivalent of money, because if I put that maintenance cost for every year I want to get. So, what I will do? I might put a kind of a money right now and withdraw every year XXX or MC amount, MC amount I am saying, or OC or sum total of this every year. So, then the value amount that I am putting today is actually present worth of all the maintenance costs. Similarly, what will be happening at the end of its life, that is supposing it was 100 rupees, today its value will be 100 divided by 1 plus I to the power n, because after 1 year value of the value of, or P, we call it P, if it is P now, after 1 year it will be P into 1 plus I, then after 2 years it will be P into 1 plus I square, and after n years it will be P into 1 plus I to the power n. So, that is the future sum of P today. So, if I know the future sum, divide it by 1 plus I to the power n, I get the present worth. So, everything I can convert into present worth. In that case, d 1 will be equals to 1, rest will be multiplied by some factor, and this factor, as simply I have done, is 1 by 1 plus I to the power n. This we can derive. I will not go too much, but I think I will require it. So, sometime whenever I require, I will come into this. So, this is called equal payment series capital recovery factor. It is a factor to take account of the interest. We will just do this little bit. If you have done a course on finance or economics, construction economics or finance, then you would have gone through in detail in this kind of things. So, this discounting factors are required. That is how you define life cycle cost. So, life cycle cost should be minimized in a way. Today concepts are there in everything. You try to look at life cycle analysis, right. It is true for any infrastructure system, buildings or other infrastructure as well. So, you try to do life cycle analysis even in terms of life cycle carbon emission, life cycle energy, life cycle everything, life cycle environmental impact and so on, everywhere you have life cycle. So, life cycle cost is important and role maintenance cost comes here, maintenance cost comes here. So, you might spend a little bit more here to see that this is less, maybe this is beneficial, this is economic. Compare life cycle cost and that will tell you what kind of decision you want to take at the initial phase. So, that is its economic implication. Now, we can define this maintenance, we can define maintenance. So, what is maintenance in the context of building? It is defined as the work required, it is defined as the work required, it is defined as the work required to restore the building or its component to a currently acceptable standard. So, we are talking in terms of restoring. What it means? It was there originally, whatever it was there, obviously I will restore it to its origin level, but current standard. So, standard might have changed, standard change, even in other situations standard change. For example, standards on earthquake design of building keeps on changing, earthquake design of structure keeps on changing, new perception, risk perception increases, changes, and therefore, you change the code. So, currently acceptable standard, but in buildings it is slightly more complicated. It is not such kind of codified standards, but taste of people will also come. Standard means standard of living here, right. Not only the standard from safety point of view or otherwise, but also standard of living. For example, people feel today you go, you do not find the floor finish that you get today, it will be all floor tiles. Many of the even middle income group MIG buildings, you will find that it is all floors are all different than what it used to be say 20-30 years back, or various fixtures, various features of plumbing system or plumbing services, you will find that they have all changed. So, it is a change of taste. So, we are talking of standard means standard of living, we are also talking of standard of living. So, currently acceptable standard. So, maintenance is related to work required to restore a building to its component to an acceptable standard. There are two processes envisaged, keeping, so restoring means keeping, that is work carried out in anticipation of failure, right, and restoring. The work carried out after failure is also there. So, one is if you anticipate the failure, you will keep the maintenance will also actually include keeping it at the right position. That means, you might do a predetermined places, even nothing has gone wrong, you might do a maintenance. Apparently, nothing has gone wrong, but it should not go wrong, therefore, you might do maintenance, which is preventive maintenance. In machines, they do it very often. For example, electrical services we were talking about the other day, transformers, they will, if it is oil cooled, they will change its oil. Every yearly they will have a shutdown, they will change the transformer oil. This is there for almost many systems, it is there. So, it is preventive maintenance, right. You schedule it of course properly. So, that is keeping it in right kind of condition, and if you do it after failure, then you have to bring it back to its state. So, that is actually restoring. So, this is preventive and later is corrective maintenance. So, these are some terminologies which might go, and it will it will go into our discussions every now and then So, we will see that where it comes actually. So, this must be understood that maintenance is, in case of buildings, maintenance is the work required to allow it to, or work required to keep its functional performance to an acceptable, currently acceptable standard. Terminologies are important, currently acceptable standard, and standard here we mean not necessarily the codes which we civil engineers all understand, but even living standard, currently acceptable living standard of the same, might be the same person, same group, same economic group, but many things should have changed, styles should have changed, could be in the upper level, but in the lower levels the modern materials one would like to replace, then do not replace with the same one, but this happens elsewhere also. for example, even other infrastructure, this happens sometimes where there is a maintenance, importance of maintenance is there. So, this is one issue. Other I said is preventive and corrective. So, our building maintenance involve both preventive as well as corrective. In fact, you would like to have as much as preventive than corrective, right. So, two parts therefore. Preventive part means planned, preventive means planned, preventive means planned, preventive means planned, right. So, planned maintenance. So, part of it will be planned, preventive will involve part plan. So, according to predetermined time. So, you actually fix up the time, right, and also predetermines interval, but this not necessarily related to deterioration. You do preventive maintenance, but the preventive maintenance goes planned and preventive maintenance. I mean, planned maintenance will involve a lot of preventive maintenance, so that future deterioration do not occur. So, building maintenance involves this, and running maintenance is some other kind of terminology used, not in really building maintenance scenario, unless it is an industrial building. When your production is running, everything is running, when you do that. So, that is what a maintenance system is. When system is functioning, if you do a maintenance, then it is running maintenance, all right. Okay, other terminology is patching, patchwork. This is important. This will be relatively important in our case. Patchwork requires removal of small parts or small area, doing maintenance in small area, not the complete thing. Replacement means you replace the complete one. So, say example wise, patchwork means I find that a floor, some damages in the floor. I mean, extreme case, let us say an industrial flooring, right, where abrasion can occur, the crawler cranes or other cranes, they move, heavy loading machines move. You might find that some portion the flooring has cracked, right, or disintegrated. So, what you do? You just remove it and repair. It is done in road very often. The black topping, some places the potholes have come and you just do patching, this patching. But supposing I decide to replace the whole of the floor, because there are a number of patches have come. So many patches have come that the cost of patch repair possibly would be more than replacing it in one go. We will see that economics a little bit later on. In that case, I do complete replacement. So, replacement is complete thing, patch means localized small, right. So, replacement is the whole elements of components, because they are functionally unsatisfactory, not necessarily that there has been damage, but functionally unsatisfactory, not able to perform its functions. For example, this room, if you look at it, flooring is timber tiles, essentially meant for acoustic reasons, footfall noise control. There should not be footfall noise if somebody is walking in. So, since it is a studio, now supposing that has become loose in couple of places. So, the noise would be there. So, it is a functional failure, although otherwise no problem, there is no difficulty in walking, but it will make noise. So, there is a functional failure. So, functionally unsatisfactory, incur high maintenance or running cost. Now, supposing too many patches starts coming, this year I do replace, next year I find there are lot more patches are coming, then I would possibly maintenance cost will become too high. So, I might replace them, we will see that, and then aesthetically unacceptable, if it looks ugly. Some cases it can happen that nothing has gone wrong, but I do not like it, I just do not look it, or it is not up to the standard of the current flooring standard from my level, I do not like it. So, I just change it. So, replacement can go because of all these cases, that there is functionally it is not performing, or it is not, maintenance cost may become high, or it is aesthetically unacceptable, right. So, this is some of the definition. Preservation is related to actually more sort of heritage structures you preserve, or even in our case preservation you do is coatings or other to so that deterioration do not occur, to preserve, So, this is what is coatings, either purpose for extending a life or protecting it, right, or to maintain the appearance itself. So, that is preservation. Cleaning is essential is, although sometimes it might be actually treated as a separate activity. For example, daily washing, cleaning, etc. of the floors and such things, well, it is usually taken as a separate activity, but certain cleaning is also required or related to maintenance, right. So, because deterioration might, it's cleaning, for example, drain pipe, gutters through which rainwater comes in. Now, if you do a maintenance before the monsoon season, it will ensure that there will be no, the water accumulation will not be there. Otherwise, it can lead to water accumulation somewhere inside the pipe and overloading, leakage of the pipe, or if there is water accumulation at the ceiling roof level itself, it might cause ingress of water into the structural elements of the roof system. First, the top level, the finishing elements, thermal insulation element, and then structural elements, and it might actually initiate corrosion process. So, therefore, you would like to cleaning become sometime as a part of maintenance work, but daily cleaning, the floor cleaning, keeping it look wise good and no dirt free and things like that, that is although can be considered as a part of maintenance work, but this is sometimes it is treated separately. There is a separate agency which might be doing it, but cleaning is also necessary for maintenance of element, otherwise they will look they can lead to deterioration and such things. So, that is other aspect. Now, this diagram I think I might write it something like this, something like this, same thing, building activity. If I look at it, building activity, I will have building activity, that is what I was calling it, building activity, just trying to do it again, right. If you look at it, new and existing, I have a better slide for this, next slide will be better, new and existing, right. So, building activity, then I can say construction, new construction and existing construction, right. So, this is what is there in the next slide it is this construction, new construction and existing construction. I mean, this is what I was calling as building activity. Now, new construction and existing construction both are included in the construction or building activities, whatever you call it, and existing may be 50% in many cases. Maintenance, where the infrastructure development is already done. For example, we have been talking about housing for all for many years and still talking about it. Now, developed countries have all such things have actually has occurred, there's or in even countries like China, where last 20-30 years they have possibly done all kind of infrastructure development. So, in such countries now it is only the maintenance, new constructions are only demolition and new constructions, demolition and then new construction, otherwise relatively. So, this cost is more than 50% in many places, including in India also it might be close to 50%, because many of them are deteriorating and so on and so forth. So, existing building, cost of repair, maintenance and repair and demolition, and that might actually, this is the importance of maintenance activity. The cost involved is quite large, right. Okay. So, this is one thing. Now, then this is alteration and renovations. Some definitions we require: alterations, one, and renovation. Certain definitions. Alteration means you are altering the spaces. You do quite often in offices, you do quite often alterations. What you do, like the, for example, civil engineering department office. Generally, you have the office catering to all academic activities, various academic activities, student interaction to the faculty's administration rather, and then possibly the administrative head is sitting there. there might be sometime a committee room, meeting room, etc. Now, quite often what you do, you want to have, you have now increased number of people, number of faculties have increased. So, you want to increase the size of the meeting room. What do? You alter. The office might become smaller because the computers have come, you do not need bigger tables, different tables. So, this is alteration, area wise, you are changing alteration. It is not a major maintenance, it is actually alteration is not really maintenance, but you do quite often. Sometimes this becomes done by maintenance department, or not sometime, almost all the time. Alteration is done by, right. Renovation is the other terminology, we will define them. Renovation, just we will stop right now and take questions from you. Renovations. Renovation is also related to alteration, renovate it to some requirement, right, which is not necessarily basically giving a new fit to both of them. Alteration is giving new fit, renovations you might add also something, renovate it to suit to your functional requirement. So, this is what it is. So, we will define some of those definitions like repair, rehabilitation, retrofit, renovations we have defined, alterations we have defined, we will define this.